Hey girls, sorry I'm not there today to teach you this exciting new way to take derivatives, but I'm sure you'll enjoy it just as well without me. But anyway, so what we're going to look at today is a shortcut to taking derivatives. So this is a way to take derivatives without applying the entire definition of derivative, which was that limit as h approaches 0. So first of all, before we get into that, we're going to review some exponent rules that we're going to need when we learn these shortcuts. So I'll just kind of go through these. This is really kind of the reverse of what we did in our review at the beginning of the year. Whereas we wanted to get rid of negative exponents, today we're going to look at writing an exponent that's on the bottom of a fraction as a negative exponent. So it really should sound familiar to you guys. So 3 over x squared can be written as 3x to the negative 2. 5 over x can be written as 5x to the negative 1. Radicals can be written as fractional exponent, or what we call rational exponents. So if you remember, 3 radical x can be written as 3x to the 1/2. So just to refresh your memory on that, the power of x underneath the radical becomes the numerator, and whatever the index here is, which on a square root defaults to 2, so that becomes 3x to the 1/2. Okay, so applying those same rules over here, cube root of x squared becomes x to the 2/3. Again, the power goes to the top, the index goes to the bottom. Okay, now if this is unfamiliar to you, again, when I come back on Friday, we'll go, I'll review some of this with you some more. But okay, so if we were given something like this on number 5, first we could simplify that, right? Like the x's can cancel out, and we get 2 over x to the 3rd. And then we can write that as 2x to the negative 3. So all the same simplification rules apply. If we look at number 5, we could first write this as 5 over x to the 1/3, right? So we're applying the rules from above. And then we can write it as 5x to the negative 1/3 to bring that x on top. Okay, so again, hopefully these sound familiar. If not, you'll get lots of practice with them, I promise. Okay, so today we're looking at derivatives, and again, we're looking at learning shortcuts, or actually rules to taking derivatives that allow you to take a derivative without applying the big definition that you had to use on your test. So first, right here is just a variety of ways you can write derivative, okay? I chose not to really go into this slide much while I'm not there, but this is the notation we're using for the most part today. So f with a little apostrophe x means the derivative. So if we have a function f of x, then this is the notation meaning its derivative. But you guys should know that. Okay. All right, so let's get started. So the first rule we're going to learn is constant rule, and this is if f of x equals just k, where k is any real number. For instance, let's say f of x equals 6, right? So that would just be a horizontal line at 6. So if f of x just equals 6, then the derivative of f of x equals 0. Easy as that. So if there's no variables in the function, the derivative is 0. So for instance, if f of x equals, actually I didn't realize it was the same, let's change this to 8. Let's say f of x equals 8, then the derivative of f of x equals 0. Not cheating there. If f of x equals negative 2, then the derivative of f of x equals 0. Okay, so anytime you have a constant, f of x is just a constant, the derivative is 0. Okay? Believe me, it's a bit tougher. Okay, so now let's look at when we have a variable. So we have more than just a number. So here's the rule. If f of x equals x to some power for any real number n, meaning that n is the exponent's a real number, then the rule is the derivative of f of x equals n times x to the n minus 1. So if you compare these two, what we're doing is we're taking that power, we're putting it out in front, and then we're subtracting 1 from that power and making it the new exponent. Okay, you guys may have noticed the pattern when we were taking derivatives. I know Aubrey did, and kind of figured this out on her own. But that's the power rule, and that really applies to any exponent, fractional, negative, etc., that we're going to look at today. So let's take a look at it. So if f of x equals x to the 8th, and we want the derivative of f of x, again, n is 8, so we're going to bring that down in front, so we get 8x, and then we're going to subtract 1 from our exponent and get 7, so the derivative of f of x is 8x to the 7th. Okay? Now, if there's already a coefficient out in front of that power, you just simply multiply n by that coefficient. So, for instance, our exponent is 5, so n is 5. We're going to bring that down in front and multiply it. So 3 times 5 is 15. X to the n minus 1 is 4. So the derivative of f of x is 15x to the 4th. Okay? Now, so on these u-tries, I'll just try them here with you. So f of x equals x to the 10. X to the 10th, the derivative is we bring that 10 down in front, 10x, we subtract 1, and we get 9. So 10x to the 9th. So much, much easier, right, than trying to take x plus h to the 10th power and multiplying it all out, and subtracting and taking a limit. Okay, f of x equals negative 4x to the 5th. The derivative of f of x, I'm going to take this 5, multiply it by that 4, becomes negative 20. X to the, subtract 1 to the 4th, negative 20x to the 4th. Okay? Okay, now when you have multiple terms, you just apply the rule to one term at a time. Okay? So, for instance, f of x equals x squared plus 5x plus 4. We apply our rules to each term. So, if this first term, n is 2, bring it in front, subtract 1, we get 2x to the 1st. Now, this next term is a little bit strange because if you think about it, that's really 5x to the 1, right? So if you brought the 1 down in front and multiplied it, you just get 5, which is fine. And then if you subtracted 1, or I'm sorry, you subtract 1 from 1, you're going to get 0, right? And that's okay. So we get 5x to the 0. And then we know that the derivative of just a constant is 0. So our first pass through, the derivative looks something like this, which is kind of odd. But when we clean that up, it really just becomes 2x plus 5. Because x to the 0, if you remember, actually equals 0. And then we don't have to write a derivative of 0. So 2x plus 5. Okay? And again, I know you guys will have questions, and we'll practice a lot, and then I'll take some questions next class. So let's try this next one. So again, taking term by term. So the derivative of g to the x, 3 times 3 is 9, x squared, because 3 minus 1 is 2. 2 times negative 8 is negative 16 to the x, right, because 2 minus 1 is 1. 9x is going to just be plus 9 because 1 minus 1 is 0, and we don't have to write x to the 0. Okay? So actually, if you see the pattern, on any x to a power, you're taking that power down by 1. Okay? So even when we get x to the first, the x actually goes away. Okay? All right, now you try these. So pause the video for a second and try these on your own, and then come back and check and see how you did. Okay, now hopefully you guys tried these on your own. So come back and look at them. So 36, x to the 8th, again 9 times 4 is 36, minus 1. 4 times negative 5 gave us a negative 20, minus 1 gives the exponent of 3. 2 to the 1st becomes just a 2, so plus 2. And then j to the x. Okay, so 12x squared, sorry about that, 12x squared minus 4x minus 7. Okay? Sorry, my board's kind of jumping around here. Okay, now, Now, the power rule applies to any type of exponent. So that's why sometimes, rather than having to deal with a rational function like this, we can rewrite it using our exponent rules and use the power rule again. So first, I'm going to rewrite this. I'm not taking the derivative right now. I'm just rewriting r to the x using the rules we looked at earlier. So I can rewrite this as 4x to the fifth, x to the minus fifth, sorry, 4x to the negative 5 minus 2x to the negative 6. So remember, I just rewrote this to get negative exponents. Okay, I did not take the derivative yet. Now, though, I've got x to a power, so I can take the derivative using the power rule and the same rules we just did. So I take this is n, I multiply it, so I get negative 20 x to the negative 6. Because remember, negative 5 minus 1 equals negative 6. So we're still subtracting. Just looks a little bit different with negative numbers. Go to the next one. N is negative 6. I'm going to multiply it. Negative 2 times negative 6 is positive 12 x to the negative 7th. Okay? And then I want to rewrite it because, again, I want to keep positive exponents. I just changed them to negative exponents to use the rule. And when I rewrite it, those exponents go back down. But just the exponents go back down, not the coefficients. So this is my final answer. Okay? So remember, first we rewrite it to get the exponents to bring the variables up top. Then we take the derivative. Then we clean it up by taking the powers back down. Okay? Let's try another one. So first, we're going to rewrite p of x as 3x to the negative 3 minus 4x to the negative 7. Now I'm going to take the derivative, which again is going to be, take that out, negative 9x to the negative 4, multiply that, positive 28x to the negative 8. Again, you have to kind of be quick with your multiplication facts. So now, when I clean it up to get my final answer, the negative 9 just stays on top over x to the 4th plus 28 over x to the 8th. Okay? So again, that's what I love about calculus. Everything you've ever learned, you're going to use this year, hopefully, and hopefully use it correctly. Okay? Now, we're going to look at some more examples with fractions. So anything we can do with real numbers or with whole numbers, we can do with fractions. So first, let's rewrite this with fractions. So first we can say x to the 3/5, right, plus x to the 1/2. Remember, the power goes on top, the index goes on the bottom. Now we can take the exponent rule, or can apply the exponent rule to take the derivative. So think about a little 1 here. So our index is, our exponent is 3. We bring that in front. We have 3/5 x. Now we need to subtract 1. So to come over to the side to give you a little heads up. So 3/5 minus 1. Right? You have to write 1 as a fraction, so it's really 3 over 5 minus 5 over 5, right, equals negative 2 over 5. 3 minus 5, negative 2, keep the denominator. So this becomes 3/5 x to the negative 2/5 plus, take the 1/2, put it out in front, 1/2 x to the, come over here, 1/2 minus 1, right? Think about it as 1/2 minus 2 over 2 gives us negative 1/2. So to the negative 1/2. So again, anything we can, any derivatives we can take with whole number exponents, we can do with fractions. So now we're just going to rewrite this. We don't have to put it back in radicals, but we do want to put those fractions on those exponents on the bottom. So if we rewrite the derivative, it's going to be 3 over 5x to the 2/5 plus 1 over 2x to the 1/2. So again, don't freak out or anything, but all I did was take those negative exponents and put it down on the bottom of the fraction. Okay. Let's try another one. Getting a little bit fancier here. So first, let's rewrite. So the first term we don't need to rewrite. It can stay the way it is. The second term, so this is really the same as 1 over x to the 8/3, right? So we can rewrite this as plus x to the negative 8/3. Okay? Now, when we take the derivative, I bring down the 4/7 x, so I'm taking that out in front. I'm subtracting 1, so 4/7 minus 7/7 give us negative 3/7. Okay, now this one, I'm going to take the index here, bring it down in front, so it becomes minus 8/3. Going to take negative 8/3 minus 3/3, right, because I'm subtracting 1. It's going to give me negative 11/3. So I can hear the groans already, but you guys know how to subtract fractions. So subtract them. So now when we clean that up, the derivative of g of x equals 4 over 7x to the 3/7 minus 8 over, got the x there, over 3x to the 11/3. So again, all I did here was take those exponents and bring them downstairs, made it positive. Okay, so let's try this one. So I'll go ahead and do this one with you guys. Okay, so first let's rewrite. So the first term's fine the way it's written, right? X to the 7/3. Good job. This is actually x to the 1/2. Remember, there's a little 1 here, and there's no index written, so it's a 2. So minus x to the 1/2. This is actually x to the 2/3, right? But we want to bring it up. So plus x to the negative 2/3. So this was just the rewrite. Now we take the derivative. We bring this down in front, 7/3 x minus 1, which is 3 over 3, right? So it gives us 4/3. So x to the 4/3. Next one, we take this power, bring it out in front, so negative 1/2 minus 1, which again, we've already done something like this. So 1/2 minus 1 gives us negative 1/2. So negative 1/2 x to the negative 1/2. And then this one, again, we bring this down in front, so it gives us negative 2/3. And then negative 2/3 minus 1 is minus 3 over 3, gives us negative 5/3. So x to the negative 5/3. Now we rewrite it. The first one looks good, stays the same. It's all positive. Minus 1/2. We bring that negative exponent down, make it positive. Minus 2 over 3 x to the 5/3. And this is the derivative. Okay, so I know we have learned a lot, but it's still much easier than applying the definition of derivative rule. So you can only imagine trying to do that to these kind of functions. So anyway, take a look, go over these notes several times if you want to, slow down, do them on a whiteboard if you want, or look at them for each homework problem. But what I want you to do now is you can work together if you'd like, but work on the homework assignments the sub has. And like I said, we will go over these on Friday when I return. But this is the power rule derivative. Okay, thanks girls. See you later.